5 ways to improve your AI models. I'll give you a solution to the one that I think is trickiest, and then I'll give you a solution to another one that other people have told me they think is trickiest. So the 5 ways to improve your model are additional quantity of data for training and evaluation. 2 is better quality of data for measure and evaluation. 3 is extending your collection of features, so adding whole new features. 4 is investigating other model architectures, and 5 is considering a more robust basket of model performance measures and error measures. So we want to mitigate against over-optimizing on precision recall, F1 score, information criteria. Any one of those, you should be considering a basket that will improve your model robustness. And performance time in the real world. Okay, so the one that I think is most tricky here is the quality of data. And a pitfall, so quality of data is accurate labeling, so consider like a fraud detection model. There could be fraudulent records that you are not capturing and labeling properly. And I think this is actually one of the biggest reasons for underperforming models in the real world in production. A particular problem that I see is data scientists that have no knowledge of user experience. And so they might trust a data set is properly labeled because they just don't know what the end user is actually expecting or what the end user is actually doing to create a situation. And so there could be omitted or included variable bias. Consider the case where a client is A/B testing different user experiences and those A/B test labels are not captured. To the data scientists, they run their job to collect out of a SQL database or whatever. They don't know that these records are actually created in the context of a different user experience, and that is an important variable that they miss, and that ends up ultimately giving the end user a result which is not as accurate as it could be. Okay, so the quality thing I think is actually huge. Other people have told me that investigating alternative system architectures is the most difficult in their book. I had one person tell me, I don't have time to get a whole new PhD in a different architecture. You don't need to do that. So here's what I would recommend to quickly iterate and test another architecture a month if I wanted to. I would get my state-of-the-art model, and you could be as accurate as 50%. It could be a relatively weak model, but if it's the best one you have, we will call that the state-of-the-art model. So get your state-of-the-art model, and then you're just trying to beat it. You're going to do a guess and check process, basically. Before you try to beat it, so training cost is really hard there, right? And it takes a lot of time, training cost and training time. So the way that we resolve that problem is we want to do feature selection. We want to make really sure that these are the only features that matter in the state-of-the-art model. So we're getting a narrow set of features, and then we want to subsample on those features. And so we have this golden evaluation test train case, which is like a pretty small segment of data. And now I can take those features and transfer them into a different architecture. I could do logistic, linear regression, XGB, neural nets, whatever. I can change these different architectures, but I'm dealing with these same features. And that will allow me to comparatively evaluate model architectures in a pretty rapid fashion. I think you can do this like one architecture a month.